Synthesis and characterization of high-chromium wet iron alloy with tribological properties solidified under a magnetic field. This study presents the microstructural characterization of high-chromium with iron alloy solidified under the influence of magnetic field. After the solidification process, the samples were analyzed using optical microscopy. Under the magnetic field condition, a better distribution of the alloying element, particularly chromium and molybdenum, is observed, which promotes the formation of finer and more homogeneous carbides. Likewise, the matrix exhibits greater compositional uniformity. Two molds made of plastic refractory material were prepared and supported by a metal mesh to provide mechanical rigidity and avoid the magnetic field to pass through during the solidification process. To reduce thermal gradients, the molds were preheated to a temperature of 1200 centigrade. This was also intended to prevent defects associated with thermal shock during pouring. Two microstructures were obtained. The first is a microstructure obtained with magnetic field. Microstructure description without magnetic field is the next. Eutectic carbide present a long red morphology aligned in a preferred direction, forming lamellar eutectic colonies. The matrix is predominantly martensited with an intermediate gray appearance. Retaining austenite is observed as a small island of dim field located in the interdendritic regions and at the border of the carbides. The carbide matrix interface is relatively straight and continuous with long contacts between the carbides and the matrix. Directional solidification produces segregation and not uniform phase distribution. Microstructural description with magnetic field. The eutectic carbides are finer, equiaxial, and uniformly distributed with a preferred orientation. The martensitic matrix is more homogeneous and continuous. Retaining austenite is present in smaller amounts and more isolated. Dispersed small island. The carbide matrix interface is more tortuous and fragmented due to the greater fragmentation of the carbides, increasing the contact area and favoring metallurgical union. The magnetic field promotes refinement, homogeneous distribution of carbides, and reduction of microstructural segregation.